So, my name is Björklou, and I'm so excited to present Epishine here at this amazing event. Within the next 5 minutes, I will give you a smart and cost-efficient solution to one of our mega challenge. Epishine has developed a solar cell that can be used indoors. But before I go into the details, I would like to start with the big picture. The world is facing a mega challenge, and that is to optimize our total energy consumption, since our energy supply is not covering our increasing demand. Did you know that 40% of the total energy consumption within the European Union is related to buildings, and 75% of the existing buildings is to be considered energy inefficient? The good news is that there are smart solutions for optimizing and automizing the indoor environment, but that is requiring billions or even trillions of sensors. And the challenge is how to power them. The traditional way to power sensors is to use wires, and wires are very reliable, but both installation cost and maintenance cost is very high. An alternative is to use batteries instead, and installation cost is lower, but since you need to replace the batteries every 1 to 3rd year, the maintenance cost is very high. The European Union estimates that we will discard 78 million of batteries per day by 2025. So from an environmental point of view, batteries is not a good solution, since only 50% of the disposable batteries are recycled. Companies like IKEA is already taking the decision that they no longer sell any disposable batteries in the stores. So, if you do not want to use wires nor batteries, what is a better alternative? Well, for the indoor environment, light is a natural source of energy. And to use the ambient light to self-power your electronics, that is both smart and cost-efficient. Self-powering electronics, that sounds almost too good to be true, doesn't it? Well, do you remember these old calculators? This one has a solar cell made of amorphous silicon to self-power this calculator. But if you are using traditional technologies in devices where there is very little light, traditional technologies fail. Why? And now we come into my favorite part of this presentation. What we have done is to measure a number of solar cells made of amorphous silicon from 3 different suppliers. And here is the first one, the second one, and the third one. If you do exactly the same measurement with solar cells from Epishine, you can see that we have a very high and even performance, and the other ones has a big spread, making them unpredictable in low light conditions. Why? A solar cell is made of different layers, and the spread in the performance comes from short circuits within these layers. Epishine has a patent production method that eliminates the risk of short circuits. And that is what makes Epishine unique compared to others. We launched our first product 2021 and our second product 2023. And already today we have a number of customers with products out on the market with our solar cell powered by light. We have a strategic partnership with Pricer, developing their next-generation electronic shelf labels powered by light. We have a project right now ongoing with ABB, and we are planning a global product launch by 2024. So we see strong growth coming years, and we are planning a positive EBIT by 2026. We just closed a bridge round taking us to mid-2024, and then we are planning a round of 40 million euros, further scaling up the indoor case, but also to expand outdoors. It is absolutely crucial that we find ways to reduce our total energy consumption, and by optimizing our buildings, we can address 40% of the total energy consumption. Epishine has developed and offering a unique solar cell to self-power your electronics. And if you are looking for a super exciting hardware company that is enabling all these amazing software companies, giving them real data, look out for Epishine and please contact me. Thank you for listening.